So in this video we're going to work on how we find the molar mass and convert between molar mass, which is in grams, and the number of moles of elements. So in this case we're looking at the element manganese. So you would look up manganese on the periodic table, which has a symbol Mn, and in that box on the periodic table for manganese, one of the numbers is the atomic mass, which is 54.9. So that's the number we're going to use when we're converting between grams and moles. So the conversion here would be 1 mole equals 54.9 grams. So when we start this, we've got 4.59 grams, and the conversion is 1 mole. Mole goes on top because that's what we want our answer to be, divided by 54.9 grams. And when you multiply that out, you get 0.0836 moles. So now we've got a certain number of moles of gold, the symbol AU for gold, and we want to know how many grams that would be. So we've got 0.099 moles of gold, and if you look up gold on the periodic table, AU, you'd see that its atomic mass is 196.97. So our conversion factor is 1 mole. Mole goes on the bottom because we're trying to get rid of that, is 196.97 grams. That's the unit we're converting to, so that's the number we want on the top. And when you multiply that out, you get 19.5, but because this number that we started with only has 2 significant figures, I have to round this answer to 20 grams. Now 20 only has 1 significant figure, but that's okay. I can't have more than 2, but I can have less than 2 for sig figs. If you're still confused about significant figures, just ask me about it before the test. Okay, so now we have the number of moles of vanadium, symbol V. Vanadium has a molar mass of 50.942 grams. So we're going to do 4.799 moles, and we want moles for our answer, we want grams for our answer, so grams has to be on the top, 50.942 over 1 mole. If we multiply that out, we get 244.5 grams. That's the final answer. It has 4 significant figures, just like the number we started with. This time we're converting from grams into moles, and we're using the element antimony, which has a symbol SB, and it has a molar mass of 121.76 grams. So 34.6 grams times 1 mole, that's what we want our answer to be, over 121.76 grams equals 0.284 moles. We wanted our answer to be moles, and so that's what we got, 0.284. It's got 3 significant figures, just like the number we started with. Now when we're converting between mass and the number of atoms or the number of molecules, we can't go right from mass to atoms, but we can convert from mass to moles, which is what we were just doing, and then we can convert from moles to atoms, which is what we have done in previous sections. So we can do a 2-step problem to get from mass around the moles into atoms. So how many atoms would we have if we had 75 grams of the element chromium? Well, chromium, with the symbol Cr, has a molar mass of 51.996 grams. So the first step is to convert from grams, because that's what we have, to moles. So we take the 75.0 grams times 1 mole, because we're converting to moles, that has to be on top, over 51.996 grams, and that equals 1.44 moles. and then I'm going to convert from moles now into atoms, because that's what the question is asking me here. So I take the 1.44 moles, and I use that to start a second conversion from moles into atoms, and 1 mole is always 6.02 times 10 to the 23rd atoms. So 1.44 times 6.02 times 10 to the 23rd is 8.67 times 10 to the 23rd atoms. Okay, so the number of atoms or molecules in a mole is always 6.02 times 10 to the 23rd. The number of grams in 1 mole depends on the element or the compound. So the number of grams per mole can change. The number of atoms or molecules per mole never changes. So keep that in mind as you're doing these problems. So we're starting now with the number of atoms, and we want our answer to be mass, which will be in grams. And we're working with the element lithium. So we have 6.88 times 10 to the 24th atoms of lithium, and as we just said, 1 mole is always 6.02 times 10 to the 23rd atoms. So we will divide 6.88 times 10 to the 24th by 6.02 times 10 to the 23rd, and that gives us 11.4 moles. We take 11.4 moles as the starting point for our second conversion, because we want our answer to be grams, not moles. So 1 mole of lithium has a mass of 6.94 grams. Look that up on the periodic table. So we would do 11.4 moles times 6.94 grams per mole, and we get an answer of 79.1 grams. That's the final answer. And the number we started with had 3 significant figures, so our answer can have 3 significant figures. How many atoms would you have in 100 grams of tungsten? So tungsten, if you're looking for it on the periodic table, it's a tricky one. It's got the symbol W, and it has a mass, it's a heavy element, 183.84 grams. So we're going to start with our 100 grams of tungsten times 1 mole over 183.84 grams, and that gives us 0.544 moles, so just over half a mole. Take that number and use it to do the second step, because we want the answer to be atoms, not moles, so we're not done yet. We have to take the second step of converting the moles into atoms, and 1 mole again is always 6.02 times 10 to the 23rd atoms. So when we multiply that out, we end up with 3.275 times 10 to the 23rd atoms. This time our starting number had 4 significant figures, so our answer can keep those 4 significant figures. What would the mass of 7.321 times 10 to the 20th atoms of lead be? So we want our answer to be in grams. We have the unit of atoms. It's a 2-step problem. We start with the 321 times 10 to the 20th atoms times 1 mole is 6.02 times 10 to the 23rd atoms, which gives us 0.00122 moles, or 1.22 times 10 to the negative third moles. We take that answer, 0.00122 moles, and now we need to convert to grams, because that's what the question is asking for. So we need the molar mass of lead. That's element symbol Pb, and it's another heavy element like tungsten, heavier than tungsten, 207.2 grams. So we're multiplying 0.00122 times 207.2 grams per 1 mole. So we end up with 0.253 grams of lead.